right, let's get rolling. I'm gonna have to pause and start. So here's kind of what we're doing. It's gonna take us today and tomorrow. So we are creating a book kind of little thing. It's got all of our linear programming notes and examples. So just a little something different. So if you printed it off, hopefully it works. You people in here, make sure you grab one, take the staple out of the corner, fold it in half, create a book. There's a stapler and you'll need a couple pencils. Okay, you get a couple minutes to get started on that while everybody else logs on. Same thing with y'all. Make sure you have your blank book. We're gonna fill it out. We're gonna do half today and half tomorrow. But you print it. If not, you can just look at it.
I won't be here in the morning tomorrow.
That's not a good choice.
Well, I'm taking a test.
All right, let's get rolling. So, what we're doing today and tomorrow is something called linear programming. Basically, we are using different equations and scenarios in order to maximize or minimize something. So a little bit of practicality can be used here. But the book, this little book is a great way to learn notes, to kind of keep things organized. On these slides, I'm gonna jump around. I have them labeled in the top corner. So like this will be page 2, and then we'll end up doing this as page 11 kind of thing. So that's why if you don't fold it in half, if you printed it, it's not gonna work out pretty. You'll just be jumping around, but to each his own, you'll be all right. So let's take a look at all of our definitions to start first. So you know what I'm talking about when I use different vocabulary words. So this is really the only real bad part. So a constraint right here. A constraint is an inequality that forms an edge of your feasible region. Feasibles with an I. So a constraint is an inequality. So remember, an inequality has a greater than or less than sign that forms an edge of your feasible region. Linear programming. I'll just keep going. Is a method to determine the maximum or minimum of an objective function. Sorry, it's a lot of writing today, at the beginning at least. So linear programming is a method to determine the maximum or minimum of an objective function. If you can't read something, just let me know. I got no problem talking again. So the feasible region here is the shaded area or the shaded region bounded by the constraints. So the shaded area or shaded region bounded by the constraints. Objective function. So the objective function is a function with two independent variables that we are maximizing or minimizing depending on what we are talking about in this area. Slide this up a bit. We're getting close. So bounded. So a bounded region. Is formed by a closed polygon. It's gonna be colored in. Ethan. So the next two, we got bounded and unbounded. So a bounded region is formed by a closed polygon. So you can actually close it, you can color it in. All the different sides of the polygon are there. An unbounded region is formed or does not form a complete polygon. So you're gonna have an open side. So that's the difference in bounded and unbounded. And the last one, the vertex principle of linear programming. That just sounds like really cool, but not really. Is the maximum or minimum of the objective function will occur at a vertex of the feasible region. So the vertex principle you will be using a lot. That's how we solve kind of linear programming. It's a long process. But the vertex principle states that the maximum or minimum of the objective function will always occur at a vertex of the feasible region. So one of the vertices, one of the vertex points, it will occur there. Yep, at least you're inside now. All right, does anybody have any questions on any of the vocab? Anybody need more time writing it down? Let's see, it's still going. Y'all have the nice little booklet. I get to go play hide and seek and hunt for the next page. So page 2, page 3, right here. Feasible region, kind of looking at our vocabulary and labeling it so we know what's going on. And some different things. So if I'm looking at this, and I can kind of look at different things. So up here, here's my graph. My constraints, I'm gonna try to box these in for you. These are my edges. So my constraints here, boom. I'm gonna change these colors, but it's okay. So my constraints will be all those edges. Those are the different edges of my feasible region. This one is bounded because it's closed. All right, my objective function, I can do this as red, is up top. This is my objective function. And I'm just gonna say X and Y are independent variables. So you got it. The feasible region is this area inside. So this is all that could be true based off of your graph. And the vertices are your different corner pieces. So here's one, here's one, here's one, and here's one. Just kind of looking at the different vocab so you know what I'm talking about. Here's where the different colored pencils kind of come in handy so everything's not gray. Or the highlighters or whatever you want. All right, so once you trace those, we're gonna head over to the steps for sketching a feasible region. And then I got to find it. I don't know where it's at. There we go. All right. Steps for sketching a feasible region. Then we will apply it. So step one, we're going to rewrite each constraint in slope intercept form if possible. So rewrite each constraint. If I need to go back, just yell at me if I went too fast. Okay, no problem. And slope intercept form. That's only if it's possible. So what we have here, that's going to be y is equal to mx plus b, but you're going to have greater than or less than signs as well, because they're inequalities. All right, step two. We're going to graph a line for each constraint. Zoom up. Step three, we're going to identify the polygon formed by each constraint. Like that. I'm going to go off. And then the last one, we're going to shade in the feasible region. All right. Anything? Questions yet? All right, sketching a feasible region. I want to look at this. So x is less than or equal to 0, x is less than or equal to, or sorry, x is greater than or equal to 0, x is less than or equal to 5, all of this stuff. So a good thing I have 5 colors. So the first one, I'm going to look at just this piece. So x is greater than or equal to 0. Once again, it helps me to write it on the right side with the x. So I just flip the signs. X is greater than or equal to 0. It's the same concept. So my x is equal to 0 here. Here's where all my x's are equal to 0. I can probably actually zoom out a little bit so we got it all. Come on. Greater than would shade to this side. This is where all your x's are greater than 0. When you're shading out, please shade very lightly because you're going to be drawing on top of things. Just shade very lightly. I'm going to do the other one now. X is less than or equal to 5. So 1, 2, 3, 4, 5. Here's where x is less than 5. Or here's where x is equal to 5, sorry. And I would shade everything less than. We'll darken everything in eventually. So right now, if I just stopped here and said, what's the feasible region? It's that area where it's in between orange and the red and they combine. Does that make sense? This would be unbounded because it goes forever, top and bottom. So now let's look at y is greater than or equal to 0. Here's where y is greater or equal to 0. Greater than 0 is above. So I'm in this kind of area. I had 6. Oops. All right, here, x plus y is less than or equal to 7. If I solve this for y, I have y is less than or equal to negative x plus 7. I'll move that x to the other side. That puts it in slope intercept form so I can graph it. So I'm gonna start up here at 7. So 1, 2, 3, 1, 2, 3, 4, 5, 6, 7. I'm gonna go negative x, so down 1 over 1, down 1 over 1, down 1 over 1. And you got your line. And it's less than, so this is everything over here. So you can start to see I'm forming a region. Keep going to my next one. So x plus 2y. So if I move that to the other side, 2y is greater than or equal to negative x plus 4. Divide everything by 2. So y is greater than or equal to negative 1/2 x plus 2. A lot of the skills aren't going to go away. So plus 2, negative 1/2. So down 1 over 2, down 1 over 2, down 1 over 2. And this side doesn't matter because it's not bounded. And we're going to shade above it. A lot of colors. Oh, I need another one. Uh-oh. Let's see how bad the yellow looks. That's too much effort. So y is less than or equal to x plus 5. So this one's already done for you. 1, 2, 3, 4, 5. X is going to go up 1 over 1. This is really the only side that matters. And I have all of this. So now we have to kind of make sense of what I just drew. Usually I'm only going to do 3 or 4. I'm not going to do 6 or 7 or 25 or however many this is. So if we're kind of looking at this, let's get rid of that ugly yellow. Let's go to brown. So I know that everything is in quadrant 1, right? So I'm going to find where they all intersect. So I can go here to here. I know there's a bound right here because that's my orange. Nothing can go to the left of that. I can also go to here. This green cuts it, and then this cuts it. So these are my vertices. And this is the polygon that's formed. So this is considered my feasible region. And then I got a black. These are considered my vertices points, my vertex points. So basically what that is saying is that anything in that little brown polygon will work in all of those equations. So anything inside of this brown polygon will work in all of my equations. And if you can understand that polygon and know how to get that one, you will be set. Kind of building it up today. We'll do all the background today, so that way tomorrow we can actually solve them. All right. Questions so far? I know I'm overloading, but it's good because you can use these on your testing quiz. All right, the testing vertices page. All right, in order to test our vertices, we're going to sketch in your feasible region. All right, next, we're going to identify and label the vertices with their coordinates. Come up here. Everybody had one, I hope. Then we're going to plug in each vertex. Into the objective function. So what that's going to look like is we're going to create a table because everything I do is a table. And I'm just setting it up to use the one on the right. There is no 4 step. I don't know why there's a 4 there. But I can make it disappear. And the 4 is gone. Magic. What's up? It's magic. All right, so let's look at this until I do something and it'll come back because I'll erase it. Oh, is this actually on the same page? Wow, I got lucky here. This is nice. All right, so my constraints here, we're gonna walk through this one. I don't know how far we're gonna get. Still got some time. I'm gonna do this one and then the vocab on the next one, call it quits. So let's go ahead and get our constraints here. So my first one, x plus y is less than or equal to 6 is solved for y. So y is less than or equal to negative x plus 6. So 1, 2, 3, 4, 5, 6, negative x. And it's less than, so that means I'm shading below. If you forget all of that stuff, come talk to me. We'll go back through it. X plus 2y is less than 8. So 2y is less than or equal to negative x plus 8. Divide everything by 2. So negative 1/2 x plus 8. But I got to divide 8 by 2, right? So he becomes a 4. 1, 2, 3, 4. Negative 1/2, so down 1 over 2, down 1 over 2. You got to be precise as to where it crosses. So less than, huh? That's a negative 1/2. -1/2 x plus 4. And I'll do the other two. X is greater than or equal to 0. And those are usually nice and simple. If you don't want to shade those and you understand that that creates the quadrant 1, I'm okay with that because that gets kind of bold. So my feasible region here, I have this point, I have this point, I have this point, and I have this point. This is what's going to create my feasible region. While we're catching up, I'm going to erase some of this shading that's pointless for me so I can have space to write on. All right, so what this tells me, my vertex points, this point is 0, 0. This point is 0, 4. This point over here is 1, 2, 3, 4, 5, 6. This point right here is 4, 2. So I'm going to come over here to my chart, and those are the points I'm going to use. It doesn't matter what order you do it. 0, 0, 6, 0, 4, 2, 0, 4. All right, and I'm going to plug those into my objective function. So my objective function was here. I'm going to plug those into my objective function. And that's how we are going to test our vertices. So I got 0 for x, 0 for y. So 3 times 0 plus 0 is 0. 3 times 6 is 18 plus 0 is 18. 3 times 4 is 12. 12 plus 2 is 14. And then 3 times 0 is 0 plus 4 is 4. All right. Two, three, four. So give me 4 pages left. It's all right. One, two, three, four. Let's go ahead and do the vocab on the next page, and then we'll call it quits for today. So 7 to page 8. Where are you, page 8? There you are. Finding maximums and minimums. So number 1, we are going to sketch our feasible region. Step 2, we're going to label our vertices. Step 3, we're going to test the vertices. Remember, that's your chart. And then step 4, we're going to determine the max and min. The objective function. So that's why we'll quit. That is where we will quit for today. I will post a video for y'all if you don't want to get on live. I will do these live tomorrow. But tomorrow I'll show you how to find the maximum and minimums and answer the equation, and then we will work through 2 examples. And we will call that for the day. So if you got any questions, let me know. Make sure you're staying on top of things and double check your grades.